Finally, we have a variable acceleration question. Now, these can be a bit confusing. What I recommend you do is write down A, V, and S, and remind yourself of which way you go to integrate and which way you go to differentiate. So if you have an A expression, like we do here, we've been told acceleration in terms of t, then to get to a velocity expression, we would need to integrate, and to get from a velocity one to a displacement one, we need to integrate. Okay, and the other way round, we differentiate. So long as you remember this, then I think you'll find answering the question easier. Okay, so we've been given an A expression here, and we've been told some initial conditions. When t is 1, s is 2, t is 3, s is 30. Find the displacement, which is s, when t is 2. So we need an expression for s in terms of t. We need to integrate to get 1 for v first, and then integrate again to get 1 for s. So integrate to 12t minus 4 with respect to t. So when we do that, we get 6t squared minus 4t plus c. We don't have any initial conditions for v and t. So we just have to keep our velocity expression like that. Next, we're going to get an s expression by integrating the v1. So when I integrate 6t squared minus 4t plus c, I end up with 2t cubed minus 2t squared plus ct plus another constant of integration, which I'm going to call d. Now, this is where we need to use these initial conditions. So plugging those in will help us to work out what c and d are. Okay, so we've got t equals 1, s equals 2. Let's plug those in first. We get 2 equals 2 minus 2 plus c plus d. So simplified, I've got 2 equals c plus d. That's what I'm going to call equation 1. That's putting these ones in. And then I'm going to get equation 2 by putting these ones in. So when I put in t equals 3, s equals 30, then I get 30 equals 54, take away 18, add 3c, add d. Let's simplify that as well. We get minus 6 equals 3c plus d. That's what I call equation 2. And then I need to solve 1 and 2 simultaneously to work out what c and d are. Okay, so when I do that, I think the easiest thing to do is to subtract, isn't it? And that will cancel our d's out. Then I end up with 8 equals minus 2c, and then I get c equals minus 4. If I sub that back into equation 1, which looks like the simpler one, then I end up with d equals 6. Okay, so what I can do now is rewrite my s equation with my c and d in it. So I have s equals 2t cubed minus 2t squared minus 4t plus 6. Okay, that's great, but it's not fully answered the question. If I do all of that, I end up with 6 of the 8 marks. So to get the final 2 marks, I need to work out what S is when t equals 2. So when t equals 2, S equals 2. You need to sort of show that you're plugging 2 into this equation in order to get a method mark. Okay, and then when you work all of that out, you end up with 6. So the displacement when t equals 2 is 6 meters.